we could try the second one, right? Did anyone that did we do the second one? The second one say that the sum over n and then minus one n of n is the use the residue sum over all the residues of f c secant. At the singularity of f, right? Now for this is 11.9, even 9.8. Now the series is 1 to infinity minus 1 no, and there's a fun that supposedly a constant and is in the range of minus pi to pi. That's fine. And that's clear. Right. So compare this with that, so f will be this one, right? And change n to z. Maybe because I didn't read it correctly. Yeah. Okay. And so let's just try. Right. What do we do first? It's not the range. It's not the proper range. So we could try the to extend it. So first, of course, you cannot extend to 0, right? This is singular at 0, right? But if we change n to minus n, then this should be equals to n plus minus 1 to infinity. And minus 1 n is just minus 1 to minus n is just minus. That doesn't change. And sine n change to minus, that will give you a minus sign, right? And n the cubic power change the minus sign, give you also a minus sign. So these two minus sign cancel, right? That would be n. Right. So it's the same, and then the limit doesn't matter. This is actually minus minus 1. So you can combine these two to get to this, except the zero term, right? So means add the two, so call this s, right? So this plus 2 is 2s equals to some minus infinity to infinity and not equals to 0. Right? Then obviously the idea is to well, remember what we get from here is the big circle integration, multiply this, and then all the residue of the secant function, which is 1/sine. We're supposedly give you this one. The rest of the residue is this sum. But then this one doesn't have the zero residue. So when we do the big circle, we need to exclude the zero term of that. So you get to get to that exclude the zero term. So the right hand side should be sum over the residue of f e I cos c at the residue of f and the zero of this one at c equals 0, right? So residue of.
And when we're doing the singularities, like
Yeah.
plugging the singularities for finding the residue, we just plug in the singularities for our FOZ function.
Yeah, this is that now I'm trying to figure that out. So this sum is sum over residue of f excluding n. I should say n is equals 0. Because this is one of the sign pi sign, right? So it has the singularity at 0. But to get to this one, we exclude the 0 residue. So we exclude the 0 term. So we need to include that in here. So c equals 0. And as you will figure out right away, this c equals 0 actually exactly the same location of the pole. There's a pole in here, right? These two actually becomes the same. Okay, this actually becomes, but generally, without knowing what the n is, you exclude the n equals 0 term, then you need to add the residue of the whole thing at the location when this secant is infinite, has a pole of this secant, which is sine pi z 0. So z is 0. Okay, that's how we get that. Now let's get to it. And so FC, so basically there's only one term because F is sine pi z over C cubed. That's F, right? And then we multiply by the secant pi z. Like I think by sine, obviously you like it's a little bit more familiar than secant, right? Right. And that is we want to find the residue at so you can see, right? And now you need to figure out the order of that one, right? At c equals 0, there's a cubic power. There's a c equals, this is also 0, but the numerator is also 0, but the 0 is also first order. It's just a simple 0. There's no multiplicity. So altogether, you cancel that, becomes a cubic power, right? And then you use the formula. Remember the formula? You remember the formula? So the cubic one, what is need to do a second derivative, right? And there's a normalization divided by n minus 1, so it's 2 factorial, right? Okay, and then multiply c cubed. This is a cubic root, right? Cubic multiply by c cubed and take the second derivative. So, hopefully, remember, I suggest that we should look that up. I mean, trusting a memory is not a good idea. And evaluate as equal 0. I suppose that that could be answered. If we do add all the derivative correctly, that should be it, right? We need to continue. Let me look that up. Only to save some time, and then check whether up to here I got it correct. This is 11. This I forgot the negative sign. So there's a negative sign. So we should check that. So there's originally in the table. This formula has a negative sign. This is fine. This is a negative sign. And the rest is fine. The rest is fine. Yeah, there's a pi factor. There's the pi factor is coming from taking a derivative, right?
No, the equation already has it.
Oh, equation has already has a pi. Oh yeah, there's a pi. Oh yeah, there's a pi here. Okay. Okay, that should do it. Do I need to continue? It's fine up to here. You know how to take the derivative and set the limit. Okay.
In class, I didn't have time to finish the last step, so for completeness, I'll just work out the last step of this derivative and see if that agree with the answer. So the next step is just to do a derivative. Of course, you can just directly take the derivative of these functions, sine function, which should be straightforward. But another way to do it is to do an expansion of both the numerator and denominator in power series of z, because we want to take the second derivative and finally set z equals 0. So if we expand up to like c squared term, we'll get the answer. So now let's do it that way. So d squared is c squared. So the numerator is just the Taylor expansion of sine, so phi z, and then after minus, and this linear term, and then the mixed term is the cubic term, so it's 5 cube c cube, and divided by 3 factorial, which is 6. And then similarly for the denominator, you have pi z, and you want to keep to the same order, and so you have pi cube c cube over 6. Right. Then we can take the binomial expansion of the denominator, put it in the numerator also, and keep up to the order of z squared, because you see that there's a z in the, so we can cancel one z factor from the numerator and denominator. So that basically, actually we can pick pi z out, right? Pi z out, cancel one z with here and cancel pi with here. So minus 1/2 e squared dc squared. So cancel with 1z, you get your phi, and minus phi cube c squared over 6. That's the numerator, and the denominator becomes in the numerator by binomial expansion. So basically it becomes 1 because you pick pi z out. So that next order is pi square c square. And originally negative sign, but you flip it to the numerator, become plus pi square c square over 6. And then obviously they can have other terms, so you have either term you have a higher order term, but they are at least one order higher, at least c to the 4th power. But anyway, we only need the c square power. All right, and now you take the second derivative. So basically only the c square term survive. all other term after you set c equals 0 will be 0, and then obviously the 0 order term, the constant term after taking the derivative is 0 also. So you just collect the c squared term. The c squared term has so this one times that one, so minus 5q over 6. And then this one times that one, so pi squared over 6, 5 times c squared. Okay, so this is positive, this is negative. And when you take the derivative c squared, you pull out a factor of 2, because one derivative gives you 2, right? And that 2 cancel with that one, so it becomes both have a 6, so 1 6. So minus 1 6. Just keeping the c squared term. You have both have a 5, so you have 5, and then you have a pi square. This one times it, there's a pi square, right? And then the other term has a minus 5 squared, because totally it's a 5 cubed, so 5 squared. Okay, and that should be it. So S will be 1/2 of that, so you can actually write S is 1/2, that's 1/12 of this one, or if you like, you put the negative sign inside, that should be fine. And then that should be the answer, and you can check whether that's consistent with the original sum. So, but this one obviously is 0 and phi is 0, so phi is 0, that is 0, and phi is pi, this should also be 0, and phi is pi, this one is also 0. And then obviously this phi, this condition, because when you apply the method, if this is not so, then the big circle may not be 0. It doesn't decays to 0 fast enough. So that should be it.